Hi, I'm Andy, and this is my lesson on static methods in Java. In this lesson, I'll first show you how to add a static method to a class. We'll then discuss the most important static method, the main method. Let's get started. Let's finish up the rectangle class that we've been working on for the last few lessons. Up here, we have a static variable that keeps track of how many rectangles have been created. We made this variable private because we don't want to allow outside code to directly access this variable and possibly change it. We made it static because its value pertains to the rectangle class as a whole. Unlike length and width, individual rectangle objects will not have their own value for this variable. Now let's add an accessor method for this static variable to allow outside code to obtain its value. Remember, methods fall into two types: requests for information and requests to take some action. This getNumRectangles method is a request for information. However, it's a request we want to send to the class as a whole, not to a particular rectangle object. That means it's a class method, also known as a static method. So we need to add the keyword static to our method header. Now let's test this static method over in our main method. We'll start by making 3 rectangle objects. Then we'll call the getNumRectangles static method. Since this is a request we need to send to the class as a whole, we invoke the method on the class itself, not on one of the objects. Then we'll print numRecs to see if it all worked correctly. Okay, so that worked well. To summarize, static methods are requests you send to a class. You invoke them by putting the name of the class, a dot, and then the name of the method. Non-static methods, also called instance methods, are requests you send to a particular instance of a class. You invoke them by putting a reference to the object, a dot, and then the name of the method. Now that we understand static methods, we can finally understand the most important static method, the main method. Up to this point, we've basically ignored all the stuff in the header. Now it's time to discuss what all these keywords mean and how the main method executes. First, we have public. That allows outside code to invoke this method. Then we have static. As we just discussed, that means we invoke this method on the class, not on an instance of the class. Then we have void. That indicates that this method does not return any information. Then the name of the method and a single parameter called args, which is short for arguments, the values passed to this method when it's invoked. The only thing here we haven't discussed in previous lessons are these square brackets after string. Those tell you that args is a special type of variable called an array. I'll discuss arrays in some later lessons, so we can continue to ignore that part of the main method's header for now. Remember that when we run our programs, which I can do by pressing this big button right here, 2 things happen. First, our 2 source code files are compiled into bytecode using the javac command. By the way, just ignore this part of the javac command. It's not important at this point. Then this java command happens. Again, ignore this part of the command. This Java command tells a Java virtual machine to execute the main method in whatever class is listed over here. In other words, this command causes the main method in the main class to get invoked. And that's how our whole program gets kick-started. To understand this whole process better, let's type Java rectangle at the command prompt and see what happens. This error should not be surprising. Our command tried to invoke the main method in the rectangle class, but that class doesn't have a main method. If we wanted to, we could add one and then our Java command would work just fine. Okay, before we go, let's explore static methods some more. Suppose when our program starts, we wanted to create a rectangle by first asking the user for its length and width. We could put that code directly in our main method, but I think it would be better to create a separate method that does that task for us. This method will be private because it will be invoked only by other code in this class. Its return type is rectangle because it will create a rectangle object and then return the address to that rectangle. The name of the method is createRectangle, and it doesn't have any parameters. In the body, we first want to ask the user to enter the rectangle's length and width. Then we need to convert those inputs from string objects to primitive doubles. Now we can create our rectangle object with new. Remember, this command returns the address of the newly created object. Typically, we store that address in a rectangle reference variable using an assignment operator, like this. But we don't need to do that here. The purpose of this method is to return the address of the created rectangle. We can do that by simply returning the address that is returned by the new command. Now let's invoke this method in our main method and store the returned address in a rectangle reference variable. Lastly, we'll print the rectangle's information. Okay, let's see what happens when we run our program. So it looks like we got an error here. Here's why. The main method was invoked on the main class, so that means the createRectangle method will also be invoked on the main class. But notice, the createRectangle method is not a static method. It's an instance method. That means it can't be invoked on the class itself. It has to be invoked on a specific instance of the class. To fix this problem, we simply need to declare createRectangle to be a static method. This line of code will now execute correctly because createRectangle is now a class method. Let's test it out. Good, so that fixed our problem. So remember, static methods cannot invoke non-static methods on themselves. They can only invoke other static methods on themselves. And that wraps up this lesson on static methods in Java. I'm Andy. Thanks for watching and coding with me today.